Okay, so this is a biography of Leonhard Euler. Okay, Euler, his last name is actually pronounced as Euler. And here's a picture of him. So, Leonhard Euler is considered to be the most prolific mathematician of all time. Okay, so most prolific. Okay, which essentially means that he did more work in mathematics than any other human who's ever lived. Okay, and really the only one who can compare with him is a man named Paul Erdős. Okay, and he's a Hungarian mathematician from the 1900s. Okay, and the big differences between the two is that Erdős did a lot of amphetamines. Amphetamines, also known as speed. So obviously this would have contributed greatly to his work output. The other big difference is that Erdős collaborated with many people. It was something like 511 different people. And Euler did most of his work alone. Okay, the most profound difference between the two, though, is that Euler was the best at during his time. Okay, and Erdős, he was a high-quality mathematician, but I don't think you can say he was the best of his time. Okay, and besides doing the most work ever out of all mathematicians, Euler also produced some incredible results. Okay, and it was in 1988 there was a publication called the Mathematical Intelligencer. Okay, and this publication essentially asked all mathematicians to send in what they think is the most beautiful equation or result from mathematics. Okay, so after everyone sent in, they compiled the best, and they found that Euler actually had 3 out of 5 of them, out of the top 5, including number 1, number 2, and number 5. Okay, so right now we're going to go over number 1, okay, because it is a very interesting equation. Okay, so number 1 we call Eulers Identity. Eulers Identity. Okay, and I'll write the equation for you so you can see it. It's e, the number e, raised to the I times pi power plus 1, and this all gives you 0. Okay, so mathematicians around the world consider this to be the most beautiful equation in all of mathematics. Okay, now if you don't have a mathematics background, this probably just looks like a bunch of letters and numbers and doesn't mean anything to you. So, I'm going to kind of break it down piece by piece and at least give you a chance to understand parts of it. So let's start with e. E is an irrational number, okay, and it's about 2.718, and then it goes on and on forever. Okay, it has an infinite string of decimals after it, and we call those numbers irrational. Okay, so why is e important? Well, one very practical example of E is the Gateway Arch in St. Louis. Gateway Arch. Okay, and the arch is actually defined by E. Okay, and one interesting feature is that the length from bottom to the very peak of the arch and the length across the arch at the very bottom both equal 630 feet. Okay, and E was first discovered around the 15 or 1600s in regards to finance. Okay, and if you have compound interest and you compound it continuously, then you end up with E. Okay, but we won't get into those details too much. So, finance and the Gateway Arch for E. And then pi, a lot of people are familiar with pi. But pi is 3.1415, and it also goes on and on forever. It is an irrational number. Okay, meaning that it has this endless string of decimals after it. Okay, and if you don't remember pi, I'll go over it really fast. So if we had a circle, okay, and we say that the length across this circle is 1, then the length around the circle would be pi, okay, which is this 3.14. So if this is 1 foot, then this would be pi feet, or 3.14 about 3.14 feet. Okay. So pi you can think of as the circle constant. At least that's how I think of it. And then probably the most confusing aspect of this equation comes from I. Okay, and I is defined as the square root of -1. Okay, and if you don't remember square roots, they're pretty simple. I'll just jog your memory. If we had the square root of 9, so this is what number multiplied by itself gives you 9. Okay, and the only number where this is true is 3. Okay, but for something like the square root of a negative number, this intuition doesn't really work because there are no numbers that we have come across at this point that you can multiply together to get -1, or any negative number for that instance. Okay, so we just gave it a symbol, and we call this the imaginary unit. Okay, and don't let the name throw you off. It's not a figment of our imagination. It's a very real thing. It has very real, tangible applications. Okay, like for instance, we can use I to describe the electricity that comes out of your wall. Okay, alternating current can be described using I. And really any system where there's a rotation, we can use I to describe it. Okay, so it does have very practical uses. Okay, so just because we call it imaginary doesn't mean it actually is imaginary. This is probably just a bad name that we gave it. Okay, and the last concept, now this isn't too difficult, but if you don't remember it, I'll refresh your memory, is exponents. Okay, exponents. Like for instance, if we had 3 to the second power, okay, this just means 3 times 3, or 3 multiplied by itself twice. Okay, another example would be 4 to the third power. So this would be 4 multiplied by itself 3 times. 4 times 4 times 4. Okay, so that's the idea behind exponents. Not too hard there. And I'll rewrite the equation for us. So we had e to the I times pi power. Okay, so this is our exponent up here, this I times pi. And then plus 1 equals 0. Okay, so it probably still doesn't seem like too much, so I'll write it in number form. Okay, so we have 2.718, and that just goes on forever. And then we raise this to the exponent of the square root of -1 multiplied by 3.14. Okay, and then we add 1 to the whole thing, and we get 0. Okay, and one conclusion you can draw from this immediately is that this quantity right here is just equal to -1. Okay, which is really quite bizarre, and truth be told, I have no intuition on this. This doesn't really make that much sense to me. We know for a fact it's true. In fact, we've known it's true since maybe the 1750s. Okay, but that doesn't mean we really understand this. Okay, so you have all of these constants, e and pi, and then imaginary numbers, and when you tie them all together, you get something so simple and so elegant. Okay, and for the longest time, we had no idea that these constants were related to each other. They seemed to come from completely different areas of mathematics. Okay, pi comes from geometry, e comes from calculus, and I we first found when dealing with equations like some number squared plus 1 is 0. What is this number? Okay, and really only I fits into this. Okay, because if you square I, you just get -1, which is its interesting property. Okay, so I believe that mathematicians give this the title of most beautiful equation because it ties together these 3 major constants with 1 and 0. So you can make the argument that these are the 5 most important numbers in all of mathematics. Okay, and Euler was the first to find this result. Okay, and like I said, he also found the number 2 most beautiful result and the number 5 most beautiful result. And the number 5 we will actually come to later in this series.